Very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 8th students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 8th. Today we are going to start a new chapter, that is chapter number 7, sound and wave motion. Right. So far, we completed the previous lesson, electric current, which is the syllabus for your test 6, which is on 30th. Now we are going to advance to that. We are in the set 6, chapter 7, which is for the next test 7, sound and wave motion. So there are two different topics there. Actually, they are connected to each other. But first we discuss about the sound, then we'll move to the wave motion. So today we are in the session number 1. So in last class, that is maybe on Friday, we are done with the electric current, the effects of electric current, various effects we have seen. So I request you all to go through that material, practice the worksheets for examination. Okay. Now we are going to start a new chapter of the sound, which is familiar for you all. Right. Everybody knows sound means you can recall these all. There are so many devices which can produce sound, as you can see on the screen. So see, speaker, headphones produced by us, and there are so many sound produced devices we can see in our day-to-day life, right? So sound is a part of our life. It is a part of our life. We cannot imagine our life without sound. That should be within the certain limit. So what is that sound actually? You should know. First we know about what is sound. So we know all these are the pictures which you can see on the screen. It may be piano, it may be guitar, it may be drums, it may be mic, right? It may be tabla, it may be a CD player. All these are the sources of sound which can capable of producing sound. Correct or not? With this all only, we are enjoying our lives. Now, first you know what is sound first. Okay? So move forward to know more about the sound. So these are our 7th chapter where we are discussing about the what is wave, wave motion, wave parameters, sound waves, speed of the sounds in different media, what is the effect of temperature, reflection of sound. So we know about these six topics in the coming days to know more and more about the sound, right? So before entering into the synopsis 1, let us go because already learned this chapter in the earlier classes. There is no definition is given here, but let me recall what is sound. So all of you know the sound is a form of energy which causes sensation of hearing. Sensation of hearing in which the eardrums will affect. So it falls on whenever the sound reaches our eardrums, there is a vibration, sensation is created on eardrums and it gives some effect for us. Such a form of energy which causes sensation of hearing by falling on eardrums is called sound. Right? Clear? So this sound is, how sound is produced? Vibration of the body. So we know sound. How sound is produced? Question is how? How means vibration. Every vibrating body produces sound. Or to produce sound, body must be in vibration. Do you agree or not? Without vibration of the body, sound cannot produce. Sometimes we cannot see the vibrations, but definitely sound is produced means there is a vibrations are there. So answer for how is sound produced means nothing but vibration of the body produces sound. Every vibrating body produces sound, no doubt. Okay. So then how sound is traveled, right? Okay, it is how sound is produced, okay, by vibration. How sound traveled? So suppose I am producing sound here. How it is reaching you? Or how is reaching my next cabin? How? So sound is traveled through a medium. Through medium. Medium means not Telugu medium, Hindi medium, English medium. Medium means the energy which carries a sound from one place to another place. It may be either solid medium, liquid medium, or a gaseous medium. Sound can travel through medium. Sound cannot travel through vacuum because there is no medium in vacuum. Right? Sound cannot travel. You might have learned in lower classes. Bell-jar experiment. Right? So, sound cannot travel through vacuum because sound required medium for propagation, medium for traveling. Right? That medium may be either solid or liquid or a gas. Suppose you are speaking here. Through air, my sound is traveling. Air is acting as a medium. Even I can travel through water also, you can able to hear. Or if you hit any metal, it also transmits sound. Correct? So, sound is a form of energy which causes sensation of hearing. And sound is produced by vibration of the body. Sound travels through medium of either solid, liquid, or gas. Sound cannot travel through vacuum. Right? The basic information about the sound before going for our synopsis. Right? So once again, I'll show you one video also based on the same sound, what exactly the sound is. That's basic introduction about the sound, right? Oh, so much big. Everything is in this video.
Sound. Sound waves require a material medium for its propagation. Therefore, a sound produced at one point is heard at some other point after some finite time. This shows that sound has some finite velocity. We can hear a variety of sounds in our surroundings. In the music room of your school, you hear the sounds made by musical instruments like flute, drums, etc.
They are playing the musical instruments. Guitar, drums, mridangam, piano, all are there.
నా లైఫ్ పార్ట్నరా 1,00,000 కన్నా ఎక్కువ ప్రొఫైల్స్ ఉన్న telugushadi.com ఉందిగా. మరి పెళ్లికై లక్షల ఖర్చు మాటేంటి? telugushadi.com వారి షాదీ ఉత్సవం నుండి ఒక లక్కీ సబ్స్క్రైబర్ గెలుచుకుంటారు అన్ని పెళ్లి ఖర్చులుని. ఇంకో 20 మంది గెలుస్తారు గోల్డ్ కాయిన్స్ ని. డౌన్లోడ్ నౌ.
సర్ఫ్ ఎక్సెల్ మ్యాటిక్ ఇప్పుడు కొత్త ప్యాక్ లో. ఈ రోజు బాగా ఆడుకున్నావా చాంప్?
ఎనీ డౌట్? ఎలా ఆడాలో నేను చూడు. ఎండిపోయిన మరక చూడు.
నో డౌట్. ఈ ఎండిపోయిన మరకల కోసం ఉంది కొత్త.
Sorry, there is a big disturbance is there.
hear car horns, cycle bells, etc. In your room, you can hear your alarm clock, the sound from the moving blades of the fan, and so on. In your school, you can hear the ringing of your school bell, other children talking, etc. Some sounds are mild, some are loud, some are shrill, and some are flat. Each sound is unique. Even if we hear them after a long interval of time, we can recognize them easily.
Nature of sound and its propagation. Sound is produced due to vibrations. Hence, a vibrating object acts as a source of sound. Sound is a form of energy which is sensed by our ears. When an object vibrates in air, it compresses the air during forward motion. The compression increases air pressure. This compression propagates away from the vibrating object. During the backward direction of the vibrating object, particles spread apart and a low pressure zone is created in air. This is called rarefaction. These compression and rarefaction
Depends on the
travel
movement of
as
air.
wave passes through the air and reach our ears. Sound can therefore be called a pressure wave. Since the air particles are displaced along the direction of propagation of sound, hence sound is a longitudinal wave. The velocity of sound, that is, the distance travelled in 1 second, depends on the medium. The velocity of sound in different media is shown in the table.
The solids, it is very heavy.
Longitudinal
Sound
waves.
travels very
Let's
fast in
consider a
solid.
spring particle system fixed to one end. When a single pull and push is given alternatively to the first particle at the other end of the system, the particles vibrate back and forth from its original position. As the particles are connected by the spring, the pull and push are also experienced by the next neighboring particle, and in turn, it is also felt by the next particle, and so on. Hence, each particle of the spring particle system moves back and forth. During the wave motion, some of the particles come close to each other while some get apart. Regions where the particles come closer are called compression, and the regions where the particles are separated are called rarefaction. The regions of compression have higher density than the regions of rarefaction. Let us mark a point on the spring and observe its motion. You will observe the point moving left and right. Such waves in which the particles of the medium suffer displacement about their mean position along the direction of propagation of waves are called longitudinal waves. These waves travel in the form of compression and rarefaction. This table gives the difference between transverse and longitudinal waves. Transverse waves. The particles of medium oscillate around their mean position in a direction perpendicular to the direction of propagation of waves. Longitudinal waves. Particles vibrate along the direction of propagation of waves.
Basic information.
Transverse waves. The waves move in the form of crest and trough. Longitudinal waves. The waves move in the form of compression and rarefaction. Transverse waves. It can propagate in solids and liquids only. Longitudinal waves. It can propagate in solids, liquids and gases. Transverse waves. Waves are of two types, transverse waves and longitudinal waves. Let us learn about transverse waves. Tie one end of a string with a rigid support and hold the other end with your hand. On moving the hand up and down, waves can be seen propagating in the string. Now mark a point on the string. You can notice that the mark moves up and down from its mean position perpendicular to the string, while the wave propagates in the horizontal direction along the length of the string. Such waves in which the displacement of the particles of the medium is perpendicular to the direction of propagation are known as transverse waves. These waves move in the form of crest and trough. Crest represents maximum displacement in the upward direction, and the trough represents maximum displacement in the downward direction. Range of hearing in humans.
See,
Sound is produced when a body vibrates.
see, we cannot hear all the sounds, sir. Some sounds we can able to hear, some sounds we cannot able to hear because Our eardrums are made to hear up to few range that we'll explain here. You already learned in the 6th and 7th classes.
We can hear the sound produced by a body which vibrates in a particular range of frequency. The range of frequencies that human ear can hear is from 20 Hz to 20,000 Hz. These frequencies are called audible frequencies, and the sound in this range is called audible sounds. Upper limit of hearing decreases with increasing age. The sound with the frequency less than 20 Hz is not audible by human beings. The sounds of frequency below 20 Hz are called infrasonic sound. Animals like elephants, whales, and rhinos can hear these sounds. Sounds of frequencies beyond 20,000 Hz or 20 kHz are called ultrasonic sounds. Animals like dogs, dolphins, and bats can hear ultrasonic sound. These types of sounds are used widely in medical field. Applications of ultrasound. Sounds of frequencies beyond 20,000 Hz are called ultrasonic sounds. Ultrasound is used to clean inaccessible parts of small objects. The object to be cleaned is placed in a solution, and ultrasound is transmitted through the solution. The ultrasound removes the dirt from the object. Ultrasound can be used to detect flaw and cracks in metal blocks used in making big buildings and bridges. Ultrasonic waves are passed through metal moldings and transmitted waves are detected. If there is any defect, the ultrasound gets reflected back, showing the defect. Bats and dolphins emit ultrasonic waves to locate and identify objects in its environment. Coming to the medical field, ultrasound is used to get the information about the internal organs like bladders, kidneys, ovaries, pancreas, etc. This technique is known as ultrasonography. Ultrasonography can also be used to examine fetus during pregnancy to detect growth abnormalities. When the ultrasound is used to examine the heart, it is called echocardiography. It is used in diagnosis of heart diseases. Reflection of sound. Like light, sound also gets reflected and obeys laws of reflection. If we shout inside an empty hall or a mountain, we will hear the same sound again a little later. The sound heard after reflection from a rigid surface is called echo. Imagine that you are standing in front of a mountain which is at a distance d from you, and let the speed of sound in air be v. Suppose you shout. The distance covered by the sound to reach the mountain and come back to you is 2d, and the time taken is t. The sensation of sound persists in our ear for about 0.1 second. Thus, to hear a distinct echo, the time interval between the original sound and the reflected sound must be greater or equal to 0.1 second. By substituting t equals to 0.1 second and v equals to 344 meters per second in air, we get d equals to 344 meters per second into 0.1 second divided by 2, which is equal to 17.2 meters. Therefore, to hear the echo distinctly, the reflecting surface should be at a minimum distance of 17.2 meters from the listener.
So less than that, we cannot hear.
At L'Oréal Group,
Okay.
we create 25,000 work opportunities for people under 30.
Please, less than 17.2, we cannot hear the echo. For hearing the echo, minimum distance should be 17.2. Okay. Just a minute. So here total sound and waves totally explained here what we are going to learn in the coming days. 3-4 session, this much we are going to learn about the
St. Pal Church in London is known as Whispering Gallery. Here, sound is echoed many times. This is due to multiple reflections from number of reflecting surfaces. Whenever sound is repeatedly reflected from a hall, it persists for a much longer duration till its intensity decreases below the audible limit. Such persistence of sound due to repeated reflection is known as reverberation. In order to reduce reverberations, the ceiling and walls are laid with sound-absorbing materials such as compressed fiberboard, plaster, or curtain. Practical applications of reflection of sound. Sound waves get reflected from the hard surfaces such as wall. Some devices such as megaphone, horn and trumpet use multiple reflection of sound to work. A megaphone prevents the spreading of sound by successive reflections confined within the tube. In this instrument, a tube followed by a conical opening reflects sound successively to guide most of the sound waves from the source in the forward direction towards the audience. Horns and trumpets are also designed to send sound in a particular direction without spreading it in all directions. A hearing aid is a type of device that is used by persons with impaired capacity for hearing. In this device, the sound enters through the conical inlet and suffers multiple reflections before entering into the narrow area of the ear. This helps in increasing the amplitude of the sound. Stethoscope is medical equipment with a thin diaphragm which is kept in contact with the patient's heart. The sound of the patient's heartbeat reaches the doctor's ears by multiple reflection of sound as shown. Generally, the ceilings of auditorium are curved so that sound after reflection reaches all corners of the hall as shown. Sometimes a curved sound screen is placed behind the stage so that the sound after reflecting from the sound screen spreads evenly across the width of the hall.
Noise pollution. Too much noise is known as noise pollution. Automobiles, buses, heavy machines in factories, loud uproar from religious, cultural and political gatherings, rock bands, loudspeakers, etc. are the main causes of noise pollution. It can cause irritability, loss of concentration, high blood pressure, headache, stress, sleep disturbances, and can even damage hearing permanently.
Right. So this is the total picture about the sound. So that video will explain us about total entire chapter about sound and more information about the sound. Okay. So what we understand is, first we are clear about the word sound. Sound is a form of energy. Is a form of energy. We learn about what is sound, how sound produced, how sound travels, and can we hear all sounds or not? So all these are the questions we are cleared. And of course, there is something shown about the wave because sound travels in the form of wave. So it is comes as a continuation. So sound is a form of energy which causes sensation of hearing by falling on retina, which is produced by vibrating body. Every vibrating body produces sounds. It travels through medium. So material medium is required for sound to propagate from one point to another point. That's why it is not, sound does not propagate through vacuum or space, because vacuum is nothing but absence of material medium. Right. So as per our audibility, we cannot hear all sounds. We can able to hear sounds between 20 hertz. Hertz is the name of the scientist unit to 20,000 hertz frequency only. Frequency is nothing but number of vibrations per second. You learn in lower classes. So if it is sound waves are having the frequency of 20 vibrations to 20,000 vibrations per second, we can able to hear. If it is either less than 20,000, less than 20, or greater than 20,000 also, we cannot able to hear. right? That is, we cannot hear either infrasonics or ultrasonics. But they have very important applications in our day-to-day life. Even though we cannot hear, they plays vital role in our day-to-day life in many fields. For our medical field, industrial field, and even military people also, they use ultrasonics in the various purposes. Right. So this is the basic information about the sound before entering into our topic. Now, when you come to the synopsis here, we'll start the first synopsis. There is a first word is periodic motion of the particles. Periodic means continuous along the same path. So before we move on to the study of nature and transmission of sound, we need to understand the different types of vibratory or oscillatory motion. So it is also vibratory motion only. So this is also a motion only. Right. So many ways there is a vibratory or oscillatory. This is called oscillation. This is called vibration. Right? A motion such as the earth around the sun, the movement of hands of the clock is referred as periodic motion. So earth revolves around the sun continuously, same orbit for years, millions of years. It is a periodic. Watch, needle. In watch also you can see the until unless the battery is complete, keep on moving a periodic motion. So a to and fro motion such as swing pendulum in the wall clock, vertical oscillation of the mass suspended spring, up and down like this, right, etc., referred as the harmonic motions. A harmonic motion in which amplitude and time period oscillation remains constant are called simple harmonic motion. They move with a constant speed, takes constant time for every rotation, every vibration, every oscillation, called as simple harmonic motion. Right? It's also called SHM. SHM to its displacement from the mean position and directed towards the mean position. Suppose see here, when you take a spring, add some mass here. When mass is there, what happens? It moves up and down. It always touches the mean position in every vibration twice. Right? So graphical representation of simple harmonic motion. So same pendulum, how it is moves, they show the graphically, they're showing the page next. See here. This is a simple pendulum, like our watch clock. Okay. So it is fixed here and it is to and fro motion. To and fro. So if you see graphically, it will present like this. Okay. The pendulum oscillates to and fro, and time taken for one complete oscillation is called time period. For example, it is see, this is the origin O. Okay, here to A it came, again came back, and B again came back. This is called one oscillation. To and fro is called one oscillation. Time taken to complete this is called time period. Okay. And the magnitude of displacements, for example, O to A is the maximum displacement on right side. This is called amplitude. The maximum displacement from mean position, either OA or OB, are called amplitude. So like there's some terminology is there by which you can get the mathematical formulas to know about the how to get the time period, how to get the amplitude. So T is equal to 2 pi under root of L by G formula is there. Very formula, famous formula. That depends on how far it is moving, how far it is vibrated. So time period is of pendulum can be calculated by this. L is the length of the pendulum and G is the acceleration due to gravity. Right? So coming class, next class we'll discuss about the wave motion, because we know about little about the sound now. Now I'll go for the wave motion and further information about the wave motion. There are, see, when you are discussing about waves, a lot of terminology will come across. What is time period, what is frequency, what is the wavelength, and the relationship between them will give one mathematical formula. Then transmission of energy. So that will gives for the types of waves what we discussed. Transverse waves and longitudinal waves. Okay. What is crest, trough, compressions, rarefaction? Again, see the difference between the transverse wave and longitudinal waves, which already you have seen in the video. Okay. Then we have the another type of waves, progressive and stationary also. We discuss in the coming days. Okay. So that's all for today. You can see the homework here. Home task, define sound, how it is produced. So sound is produced by vibrating body. So go through the material and correct the synopsis and write the answer for this question. Right? So thank you very much, students. Have a wonderful day. Thank you. So thank you, Oakley Medicine.